Okay, today is Saturday, August the 8th, 2015, and we're looking at the Northeast Pacific infrared loop. We've got Hurricane Hilda, a Category 4 storm with 135 mile per hour winds. The storm has actually weakened in the last 2.5 hours. It was a 140 mile per hour storm with 945 millibar central pressure. It's now 135 mile per hour winds and a core pressure of 950 millibar. If you go ahead and look at uh, the Central Pacific water vapor loop, we can see what's happening here. This storm is being hit by a transmitter. They're starting to surround this storm. We can see some dry air patches being installed here and here. We also see some HAARP rings moving off the back side of this storm. There's two or three of them here. Um, and we also see some what looks like steam here, and that's always accompanying uh, storms that are being hit, pulsed with power and shooting out the water vapor out of the center of the storm. We always see that. It looks like kind of like a cloud, but it's just a lot of water vapor. We can see some down here in the tail of the storm as it moves to the west northwest. We also have a spinning high. This has been parked for about 4 days. It's moved a little bit west, but as this storm approaches, if they can't control it and kill it off in a timely manner, then this high will move back over Hawaii and park itself, and that will help to slow this thing down. And they can use a variety of techniques to move it, over the north side of the islands like they did before, and then kill it off that way. They can move it into, the water temperature is a little cooler up here than it is down here. Okay, so we'll watch that carefully and see what they do next. But this is being hit. We can see dry air all around this, and that's what they do is they surround the storm with dry air, and then they go for the core. And they're already attacking this, so we'll keep an eye on that. Let's go ahead and look at the infrared loop. This is the color infrared loop. We can see the core diminishing somewhat. That is the red area. The central center of that storm is shrinking down just a little bit after they pulse it. That's what always happens. And we can see some shock waves too coming off of the backside of this. There's two or three right here. We can see that. Um, and of course, they're separating this storm from the thunderstorms down here. That's basically part one of how they attack these and kill them off as they isolate them. Okay, so let's go ahead and look at the visible loop. Here we can see a couple of shock waves. There's two, three of them coming out there. One, two, three, about 4 or 5 frames go by after we see those come out. They pulse these storms. They use a transmitter that they pulse. They turn the transmitter on for a short period and shut it off, and that's the duty cycle of the transmission. And that's what they do. They turn it on for a few seconds and shut it off, and then they wait for a time. In this case, it looks like maybe a half hour, maybe less. And we see these rings come out the center. Those are shock waves. Those are pressure waves from the water vapor exiting that storm at a high rate because of the fact that the core is heated so quickly. It generates heat so quickly that it generates those rings that come out of the center. And we also, let's go back and look at that this water vapor loop. We can see a splash pattern at the very beginning, like this second or third frame right there. You can see like a blast pattern where we see like fingers that are a blast all the way around that storm. And that indicates high pressure exiting the center of that storm as well. So there's a lot of telltale signs. Okay, let's go ahead and look at this is a wide shot, and we see high, or rather a low pressure. This has been here for about 4 or 5 days now. This is an upper level low, and this is spinning counterclockwise, and it is sucking a lot of this thunderstorm activity into the vortex, And so what's happening here, it looks like they are trying to isolate this system here by putting a transmitter here and here. And they're going to eventually just cut this off, I believe. That's what's going to happen. And also over here, we have a lot of thunderstorms that are popping up over Mexico. And these also are going to be sucked into this vortex. But what's happening with this cluster right here is that they're being blown away. This whole bottom area right here is being attacked, and they blow it away right there in the last 2 frames. So that's about an hour, hour and a half worth of work right there. Each frame of this loop is a half hour. Okay, so let's go ahead and look at the, this is the infrared loop, and we can better see what's happening right here. The bottom half of that whole cluster of storms is hit with a transmitter, and we can see some a bit of a blast pattern there. Right here, there's a ring. Right there, we can see that. Okay, so they're preventing this batch of thunderstorms from joining up with this vortex. That's the mission, and also to keep the rain out of California. We've got another high over Texas that's spinning clockwise, and that's sucking all this weather out to the east. All right, and that's basically what's happening. Let's go ahead and look at the southwest. Not much to see here. There's some minor thunderstorms popping up. They're being drawn out to the east. Here is the rainbow loop, same map. Okay, and there's the visible loop. Can't see a whole lot there. Okay, let's go take a look. This is the big picture, Northeast Pacific water vapor loop. We got a upper level low here, spinning, and we've got this big area of high pressure right here, which is spinning clockwise. We'll get to see that on the pressure map in a minute. That will serve to block all this flow. This is a big moisture flow out of the Bering Sea area. There's a low right here where the pen is, spinning counterclockwise. All of that's going to mushroom into this high and continue off to the east. And this broad area of low pressure will also keep this from dropping down and catching the jet stream flow into the west coast. So they don't want any moisture flowing into California, and this is how they do it. They generate a high, and that high dominates this whole area, and it just bulldozes all this rain and all that right out to the east. Okay, so let's go ahead and this is the infrared loop. Same story. You can see some intense showers here and right here. And this storm here is that's Hilda. Okay, let's go look at the jet stream. All the arrows are pretty much pointing to the east, which is favorable. If any one of these storms drops down, we'll get some rain, but they're not going to let that happen. All right, that's for 300 millibar, 30,000 feet. Let's go look at the. This is a 300 millibar pressure map. This is the spinning low that's off of Baja. We were just looking at. They're killing the thunderstorms here to prevent those from feeding that. And we were just looking at that. Here's that low up here. We've got one here and one over here. And then we have this big area of high pressure here, which has this pressure is consistent all the way through here and out to the east, right next to a low. So basically this is all the same pressure right here. And we got this low right here. Okay. Sea level low or sea level pressure map. We've got a high. This is the broad area of high pressure we were just talking about, and there's not much pressure difference as indicated by these isobars, which are spread apart pretty far. So there's a huge area of high pressure here, strong area of high pressure. So we're going to keep an eye on all this, and we'll do another update here as soon as we can. If anything develops with this hurricane, we'll do another one. But it looks like they are attacking this. They're isolating it, and we'll do an update as needed. Okay, so that's pretty much it. We'll do another one tomorrow. Okay.